Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show, bringing you another really fascinating guest today involved in creating a better tomorrow. Today, we have the honor of being joined by His Excellency Dr. Salem Humaid Al Marri, who is currently Director General of the Mohammed Bin Rashid Space Center in Dubai, United Arab Emirates, which is an advanced scientific and technological hub, ultimately responsible for making the UAE world leader in both space services and exploration. It was established back in 2006. It started out with only 5 engineers, but the center in the next couple of decades really expanded on a journey to be what they define as an incubator of the United Arab Emirates National Space Program, building, developing, operating a number of Earth observation satellites, providing imaging services and data to the scientific community. And among the satellites they currently operate are the DubaiSat-1 and 2. They are also responsible for the KhalifaSat, celebrated as the first satellite fully built by Emiratis in 2018. Dr. Amari's role is centered on ultimately ensuring the vision and the mission of the center are achieved through various different technical and scientific programs being run at the center. He previously held a related position at the Emirates Institute for Advanced Science and Technology, which was integrated into the center, and he currently oversees the expansion of the center, its scientific and technical development in different fields, ultimately ensuring that the center serves the stakeholders. And ultimately, one of the major goals is ensuring the achievement of domestic satellite development through Emirati engineers, as well as further space exploration. Dr. Marri has over a decade of experience in the space field. He was part of the teams which set up both the Center for Advanced Science and Technology and the Mohammed Bin Rashid Space Center, and has been involved in many of its projects, including on DubaiSat-1 and 2. We're honored to have him with us today. His Excellency, Dr. Salem Humaid Al Marri, thank you so much for taking the time out of your schedule to come talk to us for a little while.
It's a pleasure. Thank you very much for having me.
It's great having you. You know, I was taking some time to sort of read up about you, and I noticed that you got your start in telecom. Obviously, there is the connection with telecommunications and satellites, but obviously what you're doing is much bigger than that now. Talk a little bit about how you got involved ultimately in the transition over from telecom into this amazing space program.
Yeah, I mean, I had studied networking and IT-related aspects and programming in college. And then when I graduated, I started working in, as you say, telecoms. And it was basically working on mobile networks, programming the GSM stations, installing those elements on the towers, very early kind of, I would say, between engineering and technicians work, and kind of doing things with my hands. And then basically 3 years into that, or 4 years into that, I heard that there was a plan in Dubai to try and look at building a satellite and getting Emiratis to work on that. So I went for an interview, and I found out that this place doesn't exist. Actually, it's an idea on paper, and I was one of the first people to be interviewed, and I jumped at the chance. So I said, if you have me, I'm in. And I was lucky enough to be selected as one of the first engineers to start working on that satellite project. So that's kind of how I made my transition. I think a little bit of luck, a little bit of persistence from me, in saying that I would love to work in a field like space. And I didn't look at anything more than 2 years down the line. So, what's going to happen after that? Is there going to be an entity? Is this going to be something sustainable? Are there going to be other projects? I didn't care at that stage. What I cared was that I'm going to work on a satellite and that's going to go to space, and that's pretty cool.
Awesome. Awesome. And yeah, I mean, just looking at the timeline here, I mean, the concept that there was nothing there in 2006 when you show up, and now if I can just like sort of rattle some of these things off, you set up the UAE astronaut program, you put the first astronaut Hazal Al-Mansouri on the ISS in 2019. You just sent up Sultan Al-Nayadi on a 6-month mission to the ISS. In the meantime, you've also sent the Hope probe to Mars. You've built the Rashid lunar rover, and a variety of other things. Take us a little bit into how one creates basically a fully functional space program in less than 2 decades, and a little bit of what that was like as it all coalesced around you.
Yeah, it's been a journey, and we've got quite a strong team at the center. So I can go through a few of the kind of let's say a bit of that journey, but what I'd like to kind of emphasize today is, there's something pretty unique where we are today right now. And I think this is what I like to say. It's like an Arab golden age in terms of space exploration. So right now, as we speak, we have the Rashid rover orbiting the moon. We have the Mars Hope mission orbiting Mars. We have 2 or 3 satellites that we've built orbiting Earth. And we have a human in space, all at the same time. And if you told me that 3 years ago or 5 years ago, I would have said, that's a joke. So that's pretty, I think, something pretty amazing. I mean, I'm amazed when I think of the diversity of the missions, the types of missions, and that we're there all at the same time. That's something I think very unique for our country, very unique for this region, and it's a first for the Arab world. So that's why I call it a golden age, because we've never done something like this before as Arabs, as people from this region, and then to do it all at once, and have them operated from the same place, pretty much by the same people at the same time, is pretty cool. Now, how this started, as I said, there were interviews in 2005 for the idea of, why don't we build a small satellite, relatively cheap, because at the time, you're talking about Iconus, you're talking about Spot 5, you're talking about these big satellite constellations that are managed from Europe, France, and managed from the US. And pretty much those systems cost $1 billion or something like that, $500 million. And then to buy the data and to get access to that data wasn't something very easy. And Dubai government, as you know, Dubai and the UAE is going through a lot of changes in terms of construction, the Palm Islands, the World Islands. So the access to data from space was something that we wanted a lot of. So because of the lack of access and the price of that, the idea came up of, why don't we build a relatively cost-effective system, or buy a cost-effective system and then launch it and then operate it. And then that morphed into, well, if we're going to buy it, why don't we get engineers to participate in building it through a knowledge transfer program and see where it goes from there. And that's where I came in 2005 with my colleagues. And to start off, we were 3 engineers who are still at the center now. And we were tasked with to look at these international companies that work on knowledge transfer. So like Surrey Space Technologies, SSPL. We looked at companies in Italy. We looked at companies in Japan, in Germany, and also in South Korea, which was SATRIC Initiative. And that's the one we ended up going with. And one reason we decided to go to South Korea was because they did a technology transfer with Surrey in the 90s, and then were very successful in transitioning from a country or an entity that never built satellites to now a company that's building satellites for others. So if you know how to take technology transfer and understand it, then you know how to give it. And they were very willing to work with us in a partnership to kind of, teach us how to build those things and go step by step with us. So then we kicked off DubaiSat-1. An entity was established. It was called the Emiratis Institute for Advanced Science and Technology. That, as you mentioned in your opening dialogue, that was monologue, was basically morphed into the Mohammed Bin Rashid Space Center. And during the first 2 years of the center in 2006 and 2007 and 8, we started building DubaiSat-1. We ended up having about 12 engineers who worked on this knowledge transfer program. It was basically a learning experience. Immediately after we finished that project and before we launched it into space and operated it, we decided to kick off DubaiSat-2. So that the difference in DubaiSat-2 was, let's build something new. something that hasn't been built before by Satrikai, much higher resolution. So to go back to the resolution, DubaiSat-1 was 2.5 meter resolution. So relatively normal capabilities. We decided to go with a 1 meter system for DubaiSat-2. But let's build it together and let's build it from scratch. So we started the whole design process with them from the beginning, and we took about 50% of that development. Of course, the system took about 5 years to develop, so it's a much longer program. And through that system, we were able to train up to 50 engineers. And we launched that in 2013. And then from there, this is when it started really to kind of go into many different directions. So after we launched that satellite, His Highness Sheikh Mohammed Bin Rashid, the person that the center is named after, he's the Prime Minister of the UAE and a big supporter of the center. He visited the center to celebrate with us the launch and operation of DubaiSat-2. And he posed a question, why aren't we looking at planetary missions? Why don't we go to Mars? Why don't we look at something that's much more challenging? Of course, we said, that's something that we haven't thought of, that's very challenging. And he tasked us to do a 100-day study. So we had 100 days to do a study on how, if we were to go to Mars, how we would do that. And at the same time, we kicked off KhalifaSat, which continued our, Earth observation satellite objectives. So KhalifaSat started, and that was, okay, we did DubaiSat-2. Let's do a similar replica, increase the resolution to 70 centimeters, but we want to build it in the UAE, and we want to do it in our facilities. So as we are doing the satellite, KhalifaSat was from 2013 all the way up to 2018. The same time, we built our clean rooms, our testing facilities, and all of the labs in the center to make sure that we can do those activities in the UAE. So we're able to set up our ground systems, our facilities here. And of course, we built that mission successfully. Concurrently, we presented our 100-day study to the Prime Minister. It was accepted. The project was launched, and the UAE Space Agency was established, which is a federal entity that is basically owns the Emirates Mars mission, contracted us to build it, and they're in charge of the legal and regulatory. So you can see in 2014, it really took now 2 different directions. One of them was the element of us building satellites, Earth observation missions, and having our facilities and doing that. And we call that the National Satellite Development Program. And then another program was established, which was the Emirates Mars mission. And with that mission, we decided to take a similar route as we did with the Koreans, but this time with the United States. So because we hadn't built a Mars mission before, all of the, the navigation elements, all of the propulsion elements, all of those things were new to us. We partnered with the University of Colorado, the University of, where was it? University in San Francisco, I forget the name right now, and a few other universities in Arizona, as well as US industry, to go through a technology transfer, knowledge transfer, joint development approach and develop the Emirates Mars mission. Of course, that program continued, and the Emirates Mars mission was launched in 2020, arrived in Mars in 2021, and has just completed 2 years in orbit, which was actually the design phase. That was the science mission itself. Now there's talk of extending the science mission and going further, but that was really, we can say, the culmination of a successful project. And as I mentioned before, once we had kicked off KhalifaSat and built that we also got a visit from the Prime Minister again, but this time with the UAE President, His Highness Sheikh Mohammed bin Zayed Al Nahyan. They came to the Mohammed Bin Rashid Space Center. And then again, a question was, what's next? What can we do? And there was a discussion of, Arabs haven't been to, to space for about 30 years at that stage. So there was a Saudi astronaut, Prince Sultan, who flew on the shuttle in 1985. And there was a Syrian astronaut who flew on a Soyuz in 1986. And this is 2017, we're talking 2016. So it was 31 years since another Arab was in space. And the question was proposed, why don't we launch an astronaut program? But it needs to be built on 3 main fundamental elements. First of all, it should be sustainable, so a long-term program, not, let's send somebody up to space and then do nothing after that. It should be based on science. So, it should link with the objectives of the country and our national science plans. And of course, the third element, it should inspire and support, education and outreach to the kids. So that's really, then, of course, that was the kickoff of our UAE astronaut program. So as we're doing the Mars mission, as we're doing KhalifaSat, we started now focusing on human spaceflight. And we went through a selection process, and we selected 2 astronauts, Hazza Al-Mansouri and Sultan Niadi. Hazza, as you mentioned, flew in 2019 on a short duration mission on a Soyuz. It was 8 days to the ISS about 5 years ago. And as we speak now, Sultan is in space on a long duration mission. And just I think a point I want to make is when we first kicked off that program, every person I spoke to, whether it's government or private sector, said, you're not going to get a long duration mission. That's, for ISS countries that built the International Space Station. So nobody goes long duration mission except the entities that built the space station, which is true at that stage. So only the countries that built that. But we put that as an objective that we think short duration missions are important. You get a lot of benefit, but long duration missions are really where you can make it happen, where you can do a lot of experiments long term, and you can do a lot of activities over a sustained period of time and really get a lot of bang for your buck. So if you're going up there and you're spending research dollars and money to get to space and to train these astronauts, you want them there as long as you can have them. So, but that was in 2019. And, we had a lot of persistence that, we'll make sure that our program is sustainable. We'll make sure that we collaborate with all of the different partners. And today, as you see, we're on a long duration mission. Our astronauts are training in NASA. They've been training at the Johnson Space Center for about 3 years. We have 2 new astronauts we've selected as well, Mohammed Al Marri and Noura Al Matroushi. She's the first Arab woman to be selected as an astronaut. And they've been training now for a year and a half in NASA's Ascan class. So they're part of the group of NASA astronaut candidates who are coming in, and they're training with them. So, if you're able to make sure that your astronauts are training the same way American astronauts are training, then why aren't you able to take long duration missions and do EVAs and do all of the other things that other astronauts do? So luckily, of course, then, we've been talking to different parties and we managed to get this long duration mission. And Sultan is doing a great job. We're really happy with him. And of course, in a couple of weeks, I think at the end of this month, he'll be doing an EVA. So that's going to be the first time somebody from this region as well does an EVA. And as you know, EVAs are not something you buy or something you broker. It's something that is based on skill set, based on need for the ISS program, and based on that you can support the partner that you're there with. So for me, it's a lot of happiness and pride that Sultan was selected, because that means he's done the training and he's good at what he does. And the people who make these decisions at NASA and at the partnership believe that he can do it. So really, that's kind of how we got into there. Finally, I know I've been talking for long, but is the moon mission as well. So, we have that mission, and this was part of our kind of exploration of what can we do differently and what can we do that can contribute to what's happening globally. So if you look at the Artemis program, if you look at the global exploration roadmap, which is looking at the moon first and then Mars, we wanted to do something that can contribute there, but do it a bit differently. So all of these missions that I'm talking about, we spend pretty much a fraction of the cost of what other countries do. So when we're building the Rashid rover, it is a very cost-effective system. It is fully designed and developed in the UAE. It has a lot of international collaboration on the science. All of these payloads and the science work is done non-exchange of funds. So it's, a collaborative approach. And it's probably one of the smallest rovers ever to go to the surface of the moon. So it's about 10-kilogram rover. Building something that small that hopefully can survive and thrive on the surface of the moon and conduct meaningful science that can then come back and support those goals that we mentioned is very important for us. And we developed that with with a very smart group of people that we have at the center. They did it in about 2 years, so quite quick. And we're excited. I think, landing on the moon now with iSpace is not going to be something easy. It's never happened before that a private company's done that. Many companies have tried and failed. So we've got our fingers crossed that hopefully the landing will be successful on the 25th of April.
Outstanding, really outstanding. And as you were just mentioning, because Prime Minister Sheikh Al Maktoum, told you, okay, let's look further. You sent the Hope probe to Mars. It's orbiting now, and then you have Mars 2117, which is the vision of the human settlement, but you also have in shorter term a lot of things going on. You have in the strategic plan, as you were just mentioning, the Emirates lunar mission, where you're aside from rovers, you're doing a lot of fundamental science up there planned in terms of geology, in terms of the soil, and other enabling technologies. And then as a part of, it's sort of, as you were just saying, I look at that as sort of the stepping stone to, we go back to the moon, and there's resources there and technologies that help get us to Mars. Within another part of your organization is the center's space ventures, where it looks like you're really going into a lot of the fundamental science in terms of thinking about food and water and energy and everything else that will sustain a settlement at some point in the future on Mars. Talk about these two components, because I mean, it seems like they work kind of synergistically, right? We get to the moon, we have to do a lot of science there so we can get to Mars, and we got to do a lot more science so we can survive on Mars. Take us through these two parts of the program. I think they're fascinating.
Yeah, those are big parts, as you mentioned. So just to give a little bit of background as well. So all of what I just mentioned before, is predominantly a government program where we will build things internally or, contract international partners to work with us and do those things, right? Yep. And of course, I think a natural next step is to see, okay, how can we create an ecosystem here in the UAE? How can we get companies in the UAE involved in our space program? So the element of Mars 2117, where you're talking about research in water, food, and power, is very much linked to space, but also linked to national challenges of the UAE. So, we live in a pretty difficult environment here, and, water is scarce. Food is an issue, of course, growing your food. So any technologies that you develop for space will definitely be helpful for us here on the ground. But at the same time, all of that investment, it's designed to get startups, to get companies to be based here in the UAE. We have a startup hub in Dubai. Currently, we have about a database of 60 companies, and we have 15 startups that have come in now. We're working with them, and we, of course, give them contracts to do work for us, research. And the idea is that we get a bit of a private sector going in terms of the space program itself. So now these companies are supporting us in what we're doing. So that's working pretty well. The other element is looking at existing companies, big oil and gas, aluminium companies, manufacturers that already are in the country, do a lot of work for, let's say, the oil and gas sector or the aviation sector. They're huge sectors here in the UAE, but could they pivot and do something for us in space? And that's what we're working on currently. And our next satellite that we'll launch next year is called MBZ-SAT. So that one's named after the president. That's a fully designed and developed satellite in the UAE. It's about 1 ton. It's an Earth observation satellite, very large satellite, providing very high resolution. But all of the mechanical structure is developed in the UAE. All of the cabling, all of the harnessing, all of that is done by private sector in the UAE. Even the aluminium itself, the raw material is sourced from companies here in the UAE, that the aluminium smelters from the UAE. And it's eco aluminium as well. So it's powered by solar, and that aluminium is produced through solar energy. So all of the electronics, a lot of the electronics are done with private sector in the UAE. So previously we'd procure those or we'd do them in-house. So now you can see that pretty much 80% of the satellite is built by private sector companies that are existing, or the startups that we've set up in the hub that you spoke about. Right. And that's a big change, I think, in the last 3 to 4 years here in the UAE, that now we're kind of pivoting to making sure that industry gets involved, and it's working pretty well. And I think, what we have in terms of Mars 2117, we're planning to build this Mars Science City that'll be focused on companies that are doing research in water, energy, or food, and they'll be based with us in this Mars Science City. And it's basically to try and get startups involved with creative ideas that we could take to space, and then hopefully that can come down to the ground. We do provide space on our satellites for free. We are sending in May a satellite called KhalifaSat. It's a small 12U satellite that we built at the center, and we're sending 2 payloads from the startup companies on board there to space for free for them to test. And those types of payloads will be helpful for us. One of them is propulsion using water, which is quite an interesting idea. And another one is a 5G communication payload. So that could be something useful if you're on the surface of the moon. So these types of experiments are what we're trying to go with that.
And I was just wondering because as mentioned earlier on, astronaut Al-Nayati is going to be up in the ISS for 6 months, and with these rare cases, I mean, obviously that's a period of time that's about how long it takes to get to Mars, and there's been a limited amount of people that have been exposed to space for or zero gravity, low gravity for that period of time. Obviously, a very important piece of this is health, and things get kind of different for the human physiology once we get out of this atmosphere. Any interesting things happening on the UAE space program per human resilience, radiation issues, the things of that nature, which obviously we're beginning to explore. I know the SpaceX Polaris Dawn mission is going to be taking a look at some of sort of the genomics of radiation, over extended periods in space. Anything interesting happening on that front at the center?
Not with the radiation. So, I mean, what our focus in terms of UAE experiments. So, Sultan is doing a lot of experiments up there. Some of them are NASA experiments and other partners. Some of them may include elements of radiation. They do actually. So they do a lot of testing on the astronauts, looking at the typical things. The bone density, the muscle mass, radiation, the effects of pretty much everything on them. Especially if they do an EVA, they're further exposed. From a UAE perspective, we have. Most of our research is related to basically the astronauts themselves. So it's related to health. So we're looking at dentistry. There's effect on teeth. Some of our universities are focused on that, and of course also effects on his eyes and elements that are related to the astronaut himself. But we don't have a specific focus on radiation. But astronaut health is really important, and of course there's a mental element as well as the physical element. So you've got to make sure that they're happy, they're content, and they're physically fit. On the ISS, that can happen pretty much easily because you're pretty close to Earth. You can talk to your kids, you can do live sessions. Going to Mars, it's a completely different situation with the signal delay, and you can't just come back anytime. So I think we're focused as well on the mental health element. That's why that's why we're working on these analog astronaut programs. We've kicked off one of those, and we did our first mission in Russia alongside NASA and Roscosmos. I think it was in 2021, where we went into an isolation in an analog for 8 months, simulating a mission to the moon and then continuously going down. So a mission that's further away and seeing the psychological effects on the astronauts or the candidates themselves. We're also planning to do some more of those analog experiments this year with NASA at the Hira in Houston, but those are shorter durations, about 45 days. So I think some things you can do, especially the mental elements here on the ground, and some things you can do in space, but those are our focus areas.
Excellent. Could you say a few words about the Mohammed Bin Rashid Space Center's Learning Hub? Because here it seems like you're really putting a lot of time and resources. Again, in thinking of Mars 2117, you have a portfolio of astronauts today, but we need many more engineers and technologists and everything. And we got to interest that next generation. I don't have any. I got 3 kids in the house here. None of them are astronauts, but interest. But whatever. Talk a little bit about what you're doing to sort of stir up that next generation and keep them interested in thinking about the stars.
Yeah, I mean that's of course probably one of our primary objectives. So I think we do it on different phases. So if you're talking about let's say kindergarten all the way up to grade 12, that's how it works here. So we have continuous school visits every single day to the Mohammed Bin Rashid Space Center. Nice. From those different levels. So every day we get the students coming in, they go to our command and control room, they go to our clean room. Sometimes they put on the clothes, they look at what we're doing. If they're lucky, they get to talk to an astronaut if they're around, and they kind of live what's happening at the center. And we have different publications that we have, these children's books that we've created, and we have three publications basically. One is for the KG to grade 3. One is from grade 3 to about grade 8, I would say, and then from 8 to high school, basically. And whenever we have the different visits, we give them those books. We encourage them to get into space sciences, space itself, engineering. We tell them not everybody can be an astronaut. So really that's one big element that we do in terms of, and it's continuous, trying to get all of the schools coming to the center as much as possible to kind of live what we're doing in terms of space. Second thing we do is when you go into the universities, we do a lot of internship programs. We do a lot of research internships where the interns can come and work on our projects for 6 months. They can do science elements. They take the data. We work with them to try and help them. Let's say if they're, communication engineers, they can do some elements related to image processing, and they can go into that area as well. That's something that they usually don't realize. So we help them kind of push them into those types of things and make sure that they're aware of what they can do. We also have launched multiple programs where we build these small CubeSats with the universities and then launch them, and then the students operate them. We launched one of those in 2016, and we're planning very soon to launch another one. So those things also help the university students in their career direction, at least. They're engineers, but they could go anywhere. But if they want to go to space, that's how space will be, and that pretty much excites them. We do summer camps as well. So in the summer and the winter, we have these camps where people come in, they pay money to join. They have a 2-week kind of space camp where they live at the Mohammed Bin Rashid Space Center, enjoy what we're doing, and get kind of classes in physics and the maths and science, and really pick up there. So these are pretty much a lot of the elements that we do that are related to kids and kind of getting them involved. We also sponsor a lot of research in pretty much every single university in the UAE. A lot of the astronaut program research is sponsored by us with the medical universities and engineering universities, and then they do those experiments and we send them up to the ISS, or they're done with our partners in NASA. So these are pretty much the main things that we do. The last thing, of course, is when you have an astronaut in the ISS for 6 months, that's the best tool that you have. Oh, yeah. I haven't seen a better tool than that. Of these live calls with the students. So we're planning to do about 15 live calls with Sultan in every city in the UAE and every emirate. We've done 2 so far. One of them was in Dubai, in Dubai Opera, which is a venue that holds about 2,100 people, and it was packed full of kids of all ages, and they get a chance to ask Sultan a question live. And you get, obviously, it's only going to be about 20 people that can ask questions. However, that type of event really excites them. And, this is pretty much why we do what we're doing. So, you want to make sure they're inspired, but not only inspired and excited and have pride, but they need to understand why we're doing, why we're going to space and how important it is. And the key message for us is you can't really do anything on Earth today without space technology. We're dependent on it. And in many cases, and a lot of innovations come out of space technology. And we want them to know about that and to be part of it.
Outstanding. Really outstanding. I noticed that, obviously in addition to running the center, you do a lot of public-facing initiatives. I know the International Conference of Space Operations just concluded in Dubai. You're going to be at a space symposium, Space Foundation, coming up in April in Colorado Springs. What else is on your schedule as far as the next couple of months of 2023? Places that we can listen to you talk, meet you possibly, anything else that you want to highlight on the schedule, please?
Yeah, sure. So, like you said, these events are important. Some of them we host in the UAE. So we hosted the IAC as well. So one of the biggest space congresses in the world a couple of years ago. Of course, what's in my schedule is I'll be at Space Symposium. There is an ISS conference in June, I believe, that I'll be speaking at as well in the US. And I will also be at the IAC, which will be in Azerbaijan in Baku, the International Astronautical Congress. I believe that's in October. So these are the main ones that I will be at. Sometimes I go to smaller ones. I'll be in Norway as well. There's a global conference on climate observations, and that conference is really important because it kind of links with COP28, which is being hosted in Dubai. So having that big UN meeting in Dubai, there is a focus on climate change and how to track that and how to monitor it, and space technology really helps there. So these are the places that I'll be in the next couple of months.
Awesome. Well, one final question while we have you. I mean, obviously, you're thinking a lot about Mars and 2117, and obviously resources of all types. If we discuss food, water, energy, all limited. Financial resources are limited. If they weren't, what else gets you excited when you're not thinking about Mars? Is it asteroid mining? Is it floating cities on Jupiter? What else do you dream about in terms of the stars when you're not thinking about sort of the day-to-day activities of the center's plans?
Yeah, I'm a big fan of science fiction. So when
Me
you look
too.
at Star Trek and Star Wars and those types of things, that's something that I would love. If we have a warp drive, if we have the devices that allow you to beam up, what are they, the transporters, those
Oh
types of
yeah,
things, that would
teleportation.
definitely be something that I would love. But I think more realistically, I think I would love to see a small city on the surface of the moon. I think the moon is something that is pretty close to us, and if you have a small city there, similar to what you read in science fiction books as well, where it's a small city that's about 10,000 people, and tourists can go and visit there, and it's there's an economy between the moon and Earth. That is
Yep.
something that I would love to see in our lifetime. I'm not saying that's going to happen, but I would love to see it in our lifetime. That potentially, if you had enough money, you could go to a small city on the moon and have a holiday there and enjoy it, and then come back, and that there's an economic value of there being such presence on the moon itself.
Yeah.
I'd love that.
Me too. Me too. Plus the space elevators. That always seems kind of cool to me. But really, really a great story. I just, I'm wishing you and your team the most success with this as you continue to move forward at this warp speed pace that you've been on. Again, for everybody that is going to be listening to this particular episode of our show across the podcast networks, or again watching on our YouTube channel. Again, you've been listening to His Excellency Dr. Salem Humaid Al Marri, Director General, the Mohammed Bin Rashid Space Center in Dubai, United Arab Emirates. I really want to thank you again for taking the time out of your schedule to come talk to us, come educate us on these topics. Obviously, thank you for everything you're doing to advance the future of space. And as we say on our show here, thanks for helping to create a better tomorrow for so many people out there via what you do. Really, really great story. And again, wishing you the best with it.
Thank you very much for having me. It was a pleasure.